Hello and welcome. My name is Anna Waltz, and I will be teaching a little bit about recursion in C++. And, I believe this to be a very important topic because it is not just important to, C++. It is very important to a lot of different programming languages, and it's also very similar throughout different programming languages. Personally, I can speak for, Python and Java being very similar to C++ recursion. So, important topic. Now, getting into it, what is recursion? It's kind of important to know what we're talking about. The definition you get just by looking up on the internet is the repeated application of a recursive procedure or definition. Now, which is interesting definition given that, recursion is basically in the definition of recursion, which you'll see why it makes sense in a moment, I promise. So, as far as what that means for us today for C++, it basically just means that it is a function that repeatedly calls itself in this scenario. And because of that, we can basically call our function our recursive procedure up here, right? The repeated application of a recursive procedure. And in this case, the repeated application would be the calling of a function, right? So it is the repeated calling of a function, right? And, so it's a little bit complicated, but no need to worry. So basically, we need two things. We need a base case, and we need the recursive call. Now, this is basically what makes it recursive. So the recursive call is what, the function call that is why it is a recursive function, because it repeats. It's basically a type of loop. Our base case is pretty important because we do need to stop the loop or else we get an infinite loop, which would be very bad because our function, wouldn't really work that well. Now, moving on, we have a little example, mainly on the base case. I wanted to go a little bit more in detail because otherwise, here, I'm going to get my fancy little pen. So we have the start of our function, right? This is initially called, that's great. Now, let's say, since, we have a nice x minus 1 here, if we were to input -1, and since our base case is, x equals 0, we know that x would never equal 0, so it would just keep going in a loop forever and ever and ever, because it would call the function, and then immediately call the function again, and just keep going. But if this were just 1, maybe, per se, and it'd come down here, it'd skip the base case because it would not be true. 1 does not equal 0. But it'd come down here, and we'd go, okay, well, 1 minus 1. And what does that equal? Oh, well, let's see here. It would equal, not 1, but it would equal 0. And in which case, our base case would be true. So then it would, end our little loop right here, and that would kind of be the end of the recursion, and then it basically end up winding backwards, but you'll see a little bit more in our little next example here. So let's look at this. So this little program, it's not great syntax, but you kind of get the gist of it. So we have our initial function, have a little main function thingy here. This is important in our little next step. But what we're basically looking at is, this is initially called, and what it's going to do is it's going to sum up all the numbers between 1 and num. Whatever num is. Doesn't matter. It's basically just kind of doing this nice little loop-de-loop right here. And the reason that this works is because we have our little, function. We have our base case. But in this scenario, num isn't 1 yet, right? So it's going to keep going in here until num is 1, and in which case it would just return 1. Now, the reason this works for this scenario of, totaling up the numbers between 1 and num is because no matter what, we know that if we were to put in num here if we were to put in 1 here, and we ask ourselves, what is the sum of 1 through 1? Well, that answer is 1. So there's that. But, other than that, it actually is, I promise it's not too hard. But basically speaking, we go through, and all of a sudden we have our base case, and it stops this loop, and it'll end up going back. But more specifically on this next slide, we can kind of look at how the totaling actually happens here. So in our last slide, the recursion was basically, what you're returning. We're just going to write a little re right here. So basically what you're returning is you're returning num, or I'm just going to write n because I can't write very well, is going to be num plus, your function and n minus 1, right? So if we look at what all these are, that's basically what this is, right? So we're looking at the sum of 5, right? Here, let's write this out a little bit. So basically what this is asking is kind of like that. So the sum of 5 is, 5 plus the sum of, 1 through 4, right? And it's basically just going all the way down here. It's going through and through and through. Sum of 5 is 5 plus sum of 1 through 4. And then sum of 4 equals the sum of 4 and the sum of, 1 through 3, right? It's just going all the way down until we reach the sum of 1. And we know that the sum of 1 equals 1. So then we'll kind of go back through all the way up until we get to here. It's basically just analyzing specific parts of the function until it reaches like our base case or like a legitimate concrete answer, and then I'll go all the way back. So another example, which is going to be our lab back here. Oh, here. There we go. Here we have this beautiful little lab. And basically what it's doing is I have my little instructions up here. But basically we're printing out a very fancy Christmas tree. And what it's basically doing is it's saying that for each line, it is going to have an equal number of asterisks, which is, the first line will have 1 asterisk, the second line will have 2 asterisks, and so on. And all you have to do is insert, an argument number for how many lines you would like in your Christmas tree. So let's just open this up real quick and you guys can see how it looks. So if we were to just do like 4, we can see our lovely little Christmas tree. So line 1 is 1, 2 is 2, 3 is 3, and 4 has 4 little asterisks. So let's kind of see how this works. Maybe. If it so allows me. So we have our main function. Nothing special. It's just asking, number of lines, and it is calling a recursive function. So let's take a look at our recursive function. So fancy. So we have just, number of lines, and what's really important is our nice call right here. Now this is what makes it recursive, and our base case is going to be right here. So looking at this in more detail, we can see that whenever our program first starts off, it's starting with the maximum number of lines. So this is kind of what makes it a little bit more fun, is we start off with the maximum number of lines, and this is basically just, the asterisks, what we actually want to be printed, and how many asterisks we want specifically on each line. And that is what line is. It is specific to each line that I want. So as far as a recursive statement goes right over here, is you'll notice that, for our first num, it's being tacked onto the end of our little return statement right here. If you can think about what the final return might look like, this would have all of the smaller numbers, and this would have our final biggest line number, right? Which is why when I put in 4, our final line was, a line of 4 asterisks. But if I were to switch these, what is the reason I kind of think recursion is quite fun, because, the way you manipulate it is pretty interesting, because it really changes like almost your entire program. So like I modified, 1 line and I barely changed anything. But if I put in 4 again, all of a sudden we have this nice little upside down Christmas tree. But, that just kind of goes to show how, interesting, in my opinion, recursion can be. But you can go ahead and try to write this out yourselves, or you can try to write out something different. Maybe just have some fun. I would personally recommend a Fibonacci sequence. Those are pretty interesting too. If you don't know what that is, it's a very interesting set of numbers. But other than that,